So looking at the calendar, our test is next block day. So for you guys, that's Thursday. Next week is 2 days of review. So this is probably great news for most of you. Like if you feel like you got the hang of this, we're doing okay, then you get 2 days to do the review worksheet, make sure everything is cleaned up, and then we'll test on block day. So that's sort of the plan for what's coming.
Are we going to get the worksheet pages that we turned in back before the test?
Yes.
Okay.
Yes. All right, so let's look at the notes page, the provided notes page, and probably the first thing we want to do is shade in what's supposed to be shaded in. The good old copy machine didn't quite pick up. If you look really close, you can kind of see where it's supposed to be shaded, but you got to look really close. And like some of the edges are shaded, you can go ahead and shade those first, and then we'll.
I thought those were just lines, and I was like, we got to do that.
No, that's shading. So then we can answer the question. All right, you've kind of done these before in Algebra 2, so this will be a little bit of a review. The solution to a polynomial inequality is the set of all points in the plane which satisfy the inequality. We can describe the solution graphically by shading the correct region. Shading the correct region. Here we go. Less than. If it's less than, do you think we should shade above or below? Below. And if it's greater than, should we shade above or below? Above. Especially after we just said less than meant below. And then as we look at, kind of just jump into examples because we think we know how to do this. Which of the following could be the graph of that thing? So, less than means below. So we can throw out A and C because those are shaded above.
But since it's
what's the difference between B and D?
It's not equal to, so we need the dotted line.
So you got to look really close. B is a dotted line. D is a solid line.
Whoa.
Mine's shaded.
Well, this is just fine.
It's the opposite way.
You're not on the right packet.
You're not on the right packet. You're looking at the worksheet, not the notes page.
Yeah.
So, because we don't have the equal sign, you remember this? The equal sign means include the line. The not equal sign means don't include the line. So our answer is B.
Will
Is it because I wasn't here?
Will didn't get it.
Yes.
No.
Okay.
There's a lot.
Number 2. The graph of y equals g of x is shown on the right. Shade the correct part of the graph. So that one's not supposed to be shaded. Shade the correct part of the graph so that the graph is y is greater than g of x. So where am I supposed to shade on this one? Above. So that's all that means is shade above. Number 1 was B because of the dotted.
So dotted is not equal to.
Correct. So shade above for part A. Part B. Read this one carefully. State what changes you would need to be made to the graph so that it is the graph of y is less than g of x.
Dotted line.
Okay, so we would need a dotted line instead of a solid line,
It needs to be shaded on the bottom.
and we would have to shade below. All right, 3 and 4 go together, and it's really, when I first did this, I didn't recognize that until I got to number 4 and realized I probably should have done 4 at the same time I was doing 3. So there's a couple questions on the homework that are like this, so pay attention when that happens. F of x is described in this table. Which of the following is true? It would be much easier to answer these questions if I had a picture to look at. Number 4. F of x is the graph described in Table 3. On the graph on the right, sketch a possible graph of f of x. So let's do number 4 first, and then we'll have a rough picture, and then I think it'll be easy to answer these questions. So when x is less than negative 2,
So what? It's 2?
the value of f of x is negative. So starting at negative 2
We use the stable.
and going to the left, so anything to the left of negative 2,
It's like it would be.
guys, please listen, because this is a new kind of problem. When x is less than negative 2, so over here, f of x is negative, so down that way. Between negative 2 and 0, f of x is positive, so the y value is positive. And since this is a polynomial, there's nothing crazy going on, so I can't jump, I can't have asymptotes, I can't have holes, I can't do anything weird. It's got to be this nice, smooth, connected graph. So I want to be positive between negative 2 and 0. When x is 0, we're at 0. So I think we could just like do a little connection right there. From 0 to 4, we're also positive. And then from 4 on, we're negative. So, whoops, I can't have a pointy spot there. It needs to bounce there. So something like that. And again, I go back and check that. So we're negative right there. We're positive between negative 2 and 0. And we're positive again from 0 to 4. And then we're negative after that. Overkill with the colors, but it helps us see. And we don't know like how high up this goes. That's why it says sketch a possible graph. So maybe it goes way up or higher or steeper, but that's not the point of this. The point is to get the general shape right. Now we can go answer these questions. F has a relative maximum when x equals 0. Yes or no? No. At x equals 0, we're at a relative minimum, so that's a no. Because that was supposed to be a minimum there. The degree of f is at least 4. It's at least 4. How many zeros do we have? 3. Well, yeah, it kind of depends on how you count, because what's going on here?
It could be a double.
That's a double.
Or is.
It's at least a double. I guess it could be a quadruple, or a 6 or an 8 or a 10. So 3 zeros, but one's a double, so I guess we should really say there's 4 zeros. So yeah, it's at least 4. Because we don't know what else is going on. There could be some other squiggles away from what we drew. So yeah, it's at least 4, because there's 4 zeros.
How can you tell it's a double root? Is it if it's like bounces as a root?
Yes.
Okay.
If it bounces, it's a double. If it bounces, it's an even powered root. Maybe a double, maybe a 4, 6, 8, so on.
On the graph, how come between 0 and 4 you go back down? Why don't you just keep going up positively?
Between.
Go back to x equals 0.
Oh, because it told us that when x equals 0, we're at 0.
Yeah.
So I had to put a point there.
I mean on the next one. On 4, why is it back at 0?
Because it ends up negative.
Because it ends up negative, because past 4 we're negative.
Oh.
So I see what you're saying, but I would not be allowed to just shoot off way up there.
Yeah. Okay.
That would meet this, but then it wouldn't be a polynomial. I mean, I could put an asymptote there, but then it's not a polynomial.
Okay.
So good question. Yeah, how do you know it doesn't just fly up there? It's because when x is greater than 4, we're negative. And polynomials have to be nice and smooth. No jumping around. Good question. How about statement 3? The leading coefficient must be positive. Yes or no? No, because down on the right means a negative lead coefficient. So that looks like 2 only. But again, how are you supposed to answer those without the picture? I'm not sure. So draw the picture first, and then the answers, I think, become a lot easier. All right, 5 and 6, another paired question here. Because how are you supposed to answer these questions without a picture? I'm not exactly sure. So I'm going to press pause, and you draw the picture for 6 based on the info from 5. So there's my picture. That didn't look exactly like a polynomial because that should be like, rounded right there. But and those should be a little smoother. But you get the idea of what the basic shape is, and I think I can answer my questions now. Any questions about what my graph looks like? Anybody disagree? I'm just checking. I made like 3 mistakes first period, so I'm on edge for my my accuracy today. All right, so now we can answer questions. G has exactly 2 relative maximums. Relative maximums. So that would be like top of mountain type situations. How many relative maximums do we have? Oh. So
it could be 6.
We don't have 2 relative maximums, but look at the picture. Relative just means the top of the hill. So even if it's a lower hill, like that graph would have 3 relative maximums.
Oh, but since it's 3.
So I think it has 3 relative maximums. I got 3 mountaintops. One mountaintop is taller than the other 2 mountaintops, but there's 3 mountaintops. The degree of G could be 6. Well, let's count our zeros. Okay, so careful. There's a double. There's a single, and then another double. That looks like 6 to me. Remember, the bounces are double roots, so 2 there, 3, 4, 5, 6. So I will say yes. It says could be 6.
Or it could be more.
It could be more. Wouldn't be less, but it could be more. So at least 6. Could be more if there's more squiggles other places, or if instead of a double root, that's a quadruple root, something like that. The leading coefficient must be negative. True or false? True, because of the right end down there is going down. So that's a true statement. So 2 and 3. But the key to all of that is graphing the picture right. Then you can answer the questions. Uh-oh. Number 7. Determine whether the point is a solution to this polynomial. So how do you think we can do this? This is not a hard one. Do you remember how to check to see if that works? Yeah, just plug it in. So one thing to do would be to graph it and look at the point. But I don't want to do that. Let's just plug it in. So the y is the f of x. So that's 3. And so we're trying to see if 3 is less than... Oh, this is kind of annoying, but oh well.
Wait. Why is it a plus minus 2?
I plugged in negative 2 for x. Everywhere there's an x,
Shouldn't you just put minus?
in goes a negative 2. So let's see, that'd be negative 32. This is going to be negative 8 times negative 6. It's a positive 48. And then the minus 2 plus 2, those can cancel out. 48 minus 32 is 16.
I think you forgot the 3x squared.
Did I miss something?
Oh.
I sure did. I left out a minus 3x squared. Minus 3 times negative 2 squared. So those two canceled out. So that's going to be minus 3 times 4 is 12. 16 minus 12 is 4. That's one of those fortunate places where the mistake I made, I still would have got the answer correct. Because 3 is less than 4. Yes, that is true. So, yes, negative 2, 3 is a solution to that because it makes a true statement. I mean, I guess I should have included the question marks all the way until we knew for sure at the end. 8 is the same thing. Let's skip number 8 because all you're having to do is plug them in. But you got to plug in 4 of them, so pass on that. Number 9. The graph of y equals g of x is shown. Shade the correct part of the graph so that it is the graph of y is less than g of x. So where am I shading? Below. Shading below. State what changes would need to be made so that the graph is y is greater than g of x. So what changes? Yep, dotted because it's not equal to anymore, and we'd have to shade above. So I like this question number 9. It doesn't require a lot of work, but it requires some thinking. Oops, until we get to C. Write a possible equation of g that has degree 5. Well, let's pick the zeros off the graph. So x equals, my goodness, I need to get me some glasses on here. So negative 3, x equals negative 2. Good, that's a double root right there because it bounces. And nowhere does it say, hey, look for double roots. It's just we have to be alert for a bouncer means that's a double root. X equals 0 and x equals 1. Oh, that's good. Degree 5. And how many zeros did we just come up with? 5, right? Because, again, we know how to count the double root. If an Algebra 1 student walked in, and we ask them how many answers there were, they'd say 4, and we'd understand why they say 4, but there's a double root. So x plus 3, x plus 2. How does the double root show up in the equation? I'm going to square that term, and then x and x minus 1. Write an equation, so I need y equals out front to make it an equation. And it doesn't specify whether factored form or multiplied out form is preferred. Which form would you prefer? When it's in. I don't want to multiply that out either. So let's leave it like that. So yeah, that's not bad. The key thing is going from roots to factors and catching that one of those was a double root.
Would you still consider it correct if we said x minus 0 instead of putting the x?
Sure. Yeah, and some people will do that. They'll put x minus 0. It sort of emphasizes that 0 is one of the roots, and that's fine. Number 10. Write the solution to this one in interval notation. let's graph this first. And it doesn't have to be a perfect graph. Thankfully, it's factored already.
One of them's going to be 0.
Actually, look, 9 and 10 go together. Maybe I shouldn't even pointed that out, because we could have figured this out on our own. Because there's a 0 at 0, at 1,
So do we?
at -2, and at -3. -2 was a double, but here's the giveaway. It's the same as number 9. Bounce. Actually, we probably would, if we were graphing on our own, we would have started at the right end because it would have been going up. So something like that. And we already shaded below. We want to know where this graph where the graph is less than 0. So be careful about that shading. I think the shading may be misleading. My graph is less than 0, so that would mean, another way to say that is, where is the graph below the axis? Where is my graph below the x-axis? So I'm gonna highlight where it's below the x-axis. Although I need to be real careful here because it could also equal 0. So below or on the x-axis, because there's one spot in there at that double root where it's on the x-axis. So the orange is my solution. The orange is the places where the graph is below or on the x-axis. So interval notation means I need to read the answer, read the orange shading from left to right. So where does it start? Good. -infinity up to -3. Do I include -3? Yes, because the equal sign means it could be on the x-axis, so we will include -3. Where's the next spot my graph is on or below the x-axis? -2. This is kind of weird, but only -2. So there's not like a span there. It's just -2 is one of the answers. And then from 1 to 2. Oh, not 1 to 2, 0 to 1. Right. Number 11, they don't give us the picture. So we need to come up with a picture. Let's factor. Hope they were nice enough to give us one that factors. And they were. Let's see, this will be +5 and -1. So there's my zeros. Sorry, I did that quick. Okay to there? I feel like we've done that a bunch, so I did that quick. We factored, found the zeros. Now let's put those zeros on a graph. So -5, 0, and 1. And my graph doesn't have to be perfect because I'm just trying to figure out where this thing is above the x-axis. Okay, I don't have any roots, so I don't have any bounces. I need to check, I need to start on the right end because I need to know, is this thing going up on the right or is it going down on the right? And how do you know it's going up?
It's going up because it's a
because it's positive. There's that lead coefficient is positive.
But negative, it's going to be going down because it's,
So it's up on the right.
But the left is down.
And why is the left down?
It's a negative 5.
It's odd.
it's exponent.
Oh, never mind.
So odd degree means opposite. Odd means opposite. So that means it's going down on the left. Now let's see if we can fill in the gap correctly in between there with no double roots. So this should work out. So we need a cross there. We need a cross at 0 and cross at 1.
And then it'll be shaded above.
And I want to know, well, I'm not worried about shading. I want to know where the graph is above. So, I mean, yes, you could shade above if you wanted to, but it doesn't say y is greater than the graph. It just says where's the graph greater than 0. So there's where my graph is above the x-axis. Overkill? Well, it's above the
You
x-axis.
have to like write the equation after that.
What says in
Oh, yeah.
inequality notation? I bet that's supposed to say interval notation.
Don't we not include the 5 since it's just greater than?
Yep. So negative 5 to 0, but we don't want to include the 0. So parentheses for all of these points, because we don't want to include them. So above the axis, but not on the axis. And then, yeah, 1 to infinity as well.
Why don't we put like an open one? If we're not doing it.
Okay, so good question. The question was, why don't we put open circles there? The graph doesn't have open circles. The solution, like if we were going to graph the solution on a number line, those would have open circles. But the graph does not have open circles. That's a really good question. So the graph, there's the graph of the polynomial. It doesn't have open circles. Where is it above the axis? Well, not at negative 5 and not at 0 and not at 1.
I'm confused on how you determined which direction these were going.
Okay, so you're good with putting the zeros on there, but how do we know where to put things? We knew that because the lead coefficient was positive, that means it's up on the right. This is the end behavior stuff.
Yeah.
So I did that first. The first thing I drew was I know it's going up on the right. And then because the degree is odd, that means it's doing the opposite on the left. So down on the left. And then there's only one way to connect the dots after that. Literally connect the
How
dots.
come you didn't go like negative for the first one? How come you do that one was positive and the other one was negative?
This one was positive and this one was... Because if this one had been negative, that would have meant that that was a double root. Because you'd be bouncing there. So I have to cross. All of those are single roots. So they're all crossers, not bouncers. As opposed to number 12, which has multiple things going on. Anything else on number 11? All right, number 12. Write the solution to that thing using interval notation. Well, let's start putting the zeros on the graph. So x equals 0, x equals 4, x equals negative 5, and x equals 7. Anything specific or special about any of those roots? Yeah, 5's a double root. 4 is a triple root. Is a triple root going to bounce or cross? It's going to cross. It's going to cross as a squiggle. We don't really care that it crosses as a squiggle, but it's going to cross as a squiggle like x cubed squiggles. So 0, 4 is the triple root, negative 5 is the double root. That's the one I really need to be careful about because that's a bounce. And then 7 is a single root. Okay, on the right end, is this thing going up or down on the right? Why down? How'd you know that?
Y becomes x.
That lead coefficient is negative.
Be greater than or equal to -2 going for x. -2.
So down on the right.
Which is -8. That's why negative 1/2. That's 4.
Now I could.
Negative
Well, go ahead.
squared.
So it's x to the
4 times
first,
3
does
is
that mean it goes up on the
Negative
left?
2 times 4 is negative.
So how many total zeros do I have?
16 minus 10 plus 1, 6 plus 1.
Which is the degree.
3
Oops, move my face out of the way.
not greater than 7. So it doesn't work.
How many total zeros do I have? Let's see, 4.
Oh,
No, 3, 4, 5, 6, 7. Yeah, 7. And I should be going. So what does that mean for the left end? Same or opposite? Opposite. So I should be going up on the left. We can also just get there and see what happens. So I'm crossing at 7. I'm crossing at 4. Although it's got some weird squiggle, but we don't really have to make that happen. I'm crossing at 0. And I'm bouncing at negative 5. And we said it was going up on the left, so that matches. I want to know where my graph is greater than 0. So I want to know where my graph is above the x-axis. Above or on, yep. So above or on would be all of this, and then 4 to 7. So I could write it out, or I could start looking at my answer choices. Boy, A looks close. What's wrong with A?
It's that the
Yeah, I can go all the way from negative infinity to 0. I don't need to be excluding negative 5.
would it be B?
So negative infinity to 0, 4 to 7. So B looks good. X equals negative 5, 0 to 4. No, that's like, C is like completely wrong. That's the opposite answer. And I don't know what's going on with D or with E. So yeah, the answer is B. Wow, that's a hard problem because that does all sorts of stuff in B. Like that combines most of what we did in this unit. We got zeros, factoring, degree, in behavior, double roots, triple roots, crossing, bouncing, equal to versus not equal to. That's a lot going on that one. All right, so today's assignment is worksheet 8. And I think worksheet 8, somehow the copy machine worked okay, if I remember correctly. And so everything is shaded correctly. You can tell what's supposed to be shaded. Yeah. So you're good on worksheet 8. The shading worked for some reason, thankfully. All right, again, we're done with new stuff. So worksheet 8, and then worksheet 9 is the review. It's kind of a long review, but we have 2 full days to do it. So we're done with new information until till next Friday. So you got lots of time to work on those last couple worksheets. We'll throw a little bonus in here. If someone stays the video all the way through, we'll rotate my face around to entertain them. There we go. So thanks for watching. You made it all this way. You get to see me upside down. A little Easter egg for our friends at home.